Hi class, so today I am doing a quick review, going over some of the main concepts we've learned this semester and helping with some tips for your last exam. So I'm going to just review some of those statistics, and then I've got a decision tree activity for us. You've learned a lot about statistics this semester. And we started off learning about the basics with descriptive statistics. So when we talk about central tendency measures, that's the mean, the median, and the mode. Measures of dispersion are standard deviation, variance, and range. I would expect you to remember that standard deviation and variance are the more robust measures of dispersion. The most commonly used is standard deviation. Standard deviation squared is variance. For central tendency measures, we most commonly report the mean, but if we do not have normal data, we might report the median, which isn't as impacted by extreme scores, or possibly even the mode, which is frequently reported with nominal data. I do expect you to still have the knowledge and comfort level of being able to identify what level of measurement a variable is. Is it nominal? Is it ordinal? Is it interval or ratio? These also will help you in determining what statistic to run. So after descriptive statistics, we learned about hypothesis testing, and we learned about inferential statistics. Inferential statistics are statistics where we're drawing an inference or generalization from a sample to a population. When we came back from break, we learned about the basics for a t-test. Remember T for 2. A t-test is when you have an independent variable that is two groups, and that is nominal. So you're grouped into male, female, or it could be something where it's a pre-test, post-test. Could be where you've got two different groupings. If you have a between subjects design, you have an independent t-test. So an independent t-test, you can only be in one of those two groups. So I'd be placing individuals based on gender, or placing individuals perhaps on two personality dimension categories, introversion, extroversion. Again, you could only be in one of those groups. I'm then interested in comparing differences between those two groups on my outcome variable. Your outcome variable should be data. Your dependent, paired, or related t-test is when you have a within subjects design. So in this case, with the T for 2, my two groups, each participant is in both groups. So it's that pre, post, before, after, baseline. Then I'm going to give you an experiment, an intervention, a drug, and then I'm going to measure you post after that. So that's our t-tree with t-tests. After t-tests, we then started moving into the ANOVA. We started off with the one-way ANOVA. The one-way ANOVA we learned about in Chapter 9 was a between subject design. It's called a one-way ANOVA because you have one IV. Remember, IV, independent variable, we can also call factor. I also am including, but I'm not going to ask you about, there is also a one-way within subject design, a repeated measures design. And then we got introduced to a factorial ANOVA. Factorial ANOVA is when you have more than two IVs, two or more IVs, or two or more factors. With a factorial ANOVA, you are getting multiple Fs. Remember, F is the statistic that's shown with the ANOVA. No matter which ANOVA you run, it's analysis of variance. Analysis of variance is looking at what is the variance between my different conditions or my different levels or treatments or groups divided by what's going on within. We can sometimes call within error. So F is an F ratio. You would expect F to be greater than 1. We then moved on to our looking at and exploring relationships. In this case, with relationships, the two statistics that were introduced to you is the Pearson correlation and the regression. Both of these have variables that are data, right? So we moved away from looking at and comparing group differences. For ANOVA, you compare group differences. For a t-test, you compare group differences. Here, I'm looking at how are two variables related. So the most basic way of looking at that relationship is a Pearson correlation. Pearson varies between -1 and 1. When we talked about Pearson, we also talked about the coefficient of determination, which is r squared. With Pearson, I could have two variables I've collected at the same time. I've asked you about hours of sleep and I've asked you about productivity. I'm looking at how those two things are related. I would get a positive correlation or a negative correlation from that would help describe that relationship. If I've determined that relationship is one of a predictor criterion, I then might run a subsequent regression. So a regression is when you have a predictor. A predictor is analogous to the independent variable. Criterion is analogous to the dependent variable. With your regression, you would want your overall regression model to be significant. A regression model is predicting that outcome. So can I predict your exam scores by looking at the hours you studied? When we're looking across all of these different hypotheses, they all have to do with understanding hypothesis testing, understanding p-values, understanding effect size, which includes Cohen's d and eta squared, and also looking at possible mistakes we could have with these decisions. So that's type 1 and type 2 error. I encourage you for a lot of those bigger pictures items that we had discussed prior to spring break to review those review materials. I also have a decision tree handout for you to look at and fill in based on your knowledge of the study design. I will be giving you some scenarios that review kind of here's a study design. What statistic would you run? What would you consider the independent variable? What would you consider the dependent variable? If I gave you an F and I gave you the P, would you be able to determine, did we reject the null? Did we fail to reject the null? What conclusions can we make? If I give you a decision with T and then I might give you a Cohen's d, could you make a distinction of what's happening in this data? Could we have an issue of power and it could be a type 2 error? Could we have a type 1 error? And so making those distinctions. I do have some review exam questions. It's not graded, it's optional for you to take. I also have, if you're interested, so the decision tree, your decision tree will look something like this. And then you can go through and answer some of those questions. If you see the mark of no, the no sign, I'm not going to be asking you about that. Those are things we might not have emphasized this semester. I encourage you, if you're trying to say, well, do I really know? You can go through. You can have a family member or a roommate open up your textbook. They'll see it's chapter 9 ANOVA. They'll read you a problem and then they can ask you, what statistic would that be? And then they would know the answer, and then you would be able to kind of rationalize, why would I run an ANOVA versus a t-test? If I gave you a question and I only gave you 2 groups, levels, conditions, I wouldn't put a t-test as an option and the ANOVA as an option because I realize in that case you could run either one. There is also a program on the web. They also have an app for StatHand. So Peter Allen and some of his colleagues had gone through and examined what students need to know, giving refresher. And so it asks you different things like, what are you wanting to do? So a relationship or association between variables. If you click on this, this is going to kind of lead you down the path of correlation or regression. If you're trying to compare samples or describe a sample. So you can kind of explore this. Some of the language or jargon might be a little bit different for you, but it could give you an opportunity for practice. So here I could say I'm examining the relationship between two variables, and then I know I'm going to have two variables, interval ratio, and then my second variable is going to be interval ratio, and then voila, it's the Pearson. So you can find your way through some of the material we have covered, but I will warn you, it goes extensively into a lot of different statistics that you can run. So I do again encourage you to review some of the materials I have posted. Reach out if you have any questions, and thank you for watching this video.